Corporate finance, practice problem with the help and use of Excel, future value of an annuity calculation. Don't leave profits solely to chance. Instead, use corporate finance. Here we are in our Excel worksheet. If you're following along with the Excel worksheet, we're in the Practice tab, Practice 1 tab. We have 2 practice problems that we will be working with, Practice 1 tab, Practice 2 tab, and 2 example tabs, which have the answer to it. We're going to be doing the future value of an annuity in a couple different ways, in a couple different scenarios. We will do that with the annuity calculation in a mathematical formula. We'll also run basically a running balance for the annuity calculation so we can see it over time, and then we'll do it with tables as well and using an Excel formula. So it's going to be great here. So we have the future value of an annuity information up top. The investment per period, we're saying that it is an annuity, so we're putting $12,000 in. So we're thinking if I continue to do that for 9 years, 9 periods, the periods being years in this case, and use a percentage rate of 7%, then how much would I have at the end of that time period? So this is kind of like the opposite of what we saw in a prior problem, which was how much would I need to be putting in a lump sum, say today, in order to receive a certain amount for a set time period. But we're using the same kind of annuity calculation now, thinking of, well, if I can have this much that I was to put in on an annual basis each year at this rate, over this certain amount of time, how much would I have then at that future point? Well, we'll use first the formula, which is going to be down here, and then we'll calculate it a little bit more easily with the Excel worksheet as well. So we have P times 1 plus R to the N, the P being the payment, minus 1 over R. We're going to use a fairly, little bit more detailed worksheet because this is going to be a longer type of problem, breaking this out into a vertical like table format. What we're going to have is in the outer column, P on the outer column times this whole thing. That's what I want to have in the outer column here. And then in the inner column, I'm going to put the numerator and denominator. That's what I'd like to have in this inner column. And this numerator, given the fact that it's going to be a bit more long of a calculation, we're going to pull this amount into this inner column. So let's see how we might set this up in a vertical type of Excel worksheet. You can use, of course, algebra to figure this as well in a traditional algebraic format. So I'm going to say the payment's going to be the $12,000. So I'm going to put that in the outer column because that's going to be the P times something. Then I'm going to move into the inner column in order to calculate this inner subset here. So I'm going to bring this whole thing in, the 1 plus R to the N minus 1. So I'm going to bring that basically inside here. So I'm going to start with the 1 here, and then I'm going to say the rate is going to be equal to the 7%. Adding those up, I'm going to first percentify this. Home tab, numbers, percentify, adding a decimal. We don't really need to right there, but I'll add it anyways. Home tab, font group, and underline. Then I'll add these up. It's going to be equal to the sum of these two items. 1 plus 7% is going to give us, if we percentifying it, 107%. We're going to take that to the power of the number of periods, which in this case is in years, not months. Just note that we have to take whatever units that we are in, 9 years in this case. And then I'm going to multiply that out. Let's put an underline here, underline, and then multiply. We're not multiplying, we're doing to the power of. So 107 to the power of, which is shift 6, the caret, the power of 9. And then we're going to say, let's go to the home tab, numbers, and add some decimals there so we can see it a little bit more accurately. And then I'm going to subtract out the 1. Let's get 1 less decimal. That's 1 too many. And then let's take out the 1. We're going to underline that. Home tab, font group, underline it. And I'm going to pull this then into the column to the right-hand side. So I'm going to say this is going to be equal to this number minus 1. So now, in essence, we have the numerator. So I'm going to add some decimals to it, though, by going to the home tab and then numbers, adding some decimals, make it a little bit more exact. Then we're going to be dividing by R. So we got the numerator. We're going to put the denominator here. So R being the rate, that's going to be the 7%, which needs to then be percentified and underlined. So home tab, number, percentify, and then home tab, font, underline. Now I'm going to pull this to the outside now. So that'll give us basically this whole component at this point, which will multiply times P, which we put up top. So this is going to then be this numerator divided by the denominator. And let's add some decimals, home tab, numbers, decimals, more decimals, and then home tab, font group, underline, and that's going to give us the bottom line, the final result, the actual thing we've been waiting for, which is going to be the 12,000 times this thing, 11.977 we just calculated. Let's add a decimal or two to that. Home tab, numbers, a couple decimals there, and there we have it. 143,735.86 is what we would expect then the future value to be. So let's type it in, future value. So that's what we have there. Now, if I was to construct the table for that rate, I'm going to take this number divided by that 12,000, and that's what you would expect to find on the table, although it's not going to go out to that many digits. So we'll see that shortly. Now let's think about this in terms of like an annuity type of calculation, and this can kind of be useful for us to clarify how this might look from period to period. Note that most people don't know how to do this, and they also probably don't know how to do the math over here either. They're just going to magically put this into a financial calculator or an Excel worksheet. But you want to have a better understanding of it, and it's really useful to do these running balance type tables to get a better handle of these kind of scenarios. So I'm going to put the periods here, 1, 2, and then I'm going to highlight those two and use the autofill, put my cursor on the autofill handle, left clicking, dragging down, and then auto drives it down, and Dr. Phil does the calculations to bring it down there. And then we're going to say that we have the payment is going to be the 12,000. So I'll just pick up that 12,000 here. The value then is going to be starting off at the 12,000 after the first payment. Now we're going to have interest that's going to be adding to this each time, and it's going to be changing on the value. So the current value is the 12,000. So I'm going to say this is going to be equal to the 12,000 times the rate, which we said was the 7%. 7%. That's going to be the interest of the 840. And then we're going to have this, after the second period, we're going to have the same 12,000 again, because we're putting in 12,000 like each period, each year in this case. So if I add that up, then last time we had 12,000 plus now we got the sum of the 840 and the 12,000. We're now at, closing the brackets, 24,840. Let's do it again. We're going to say, well, what would be the interest on that? Well, now we got 24,840 times the 7%. Notice it's an annual percent, so I don't have to deal with like dividing by 12 for a monthly percent or anything, but be careful of that if you are doing it on a monthly basis. The 12,000 is going to be the same again. So now we've got the 24,840 plus the sum of another 1,739 plus the 12,000 that we're putting in. So now we're at the 38,579. It's starting to grow like faster. So this is getting exciting. So we're going to take that 38,579 times another 7%. Notice there is rounding involved here. And it's like, well, now that interest is now 2,701, and I'm putting in another 12,000. So let's say we're going to say this is the 38,579 plus the sum of these two, and close that up. It's like, wow, that's starting to grow even faster. This is exciting. Let's do it again. We're going to take the 53,279 times the 7% this time. And then the 12,000 we're going to put in again. So this is going to be equal to the prior balance plus the sum of those two. And now we're at the 69,009. It's like, so this is really nice. But now what if I don't want to do the math anymore. I just want to see it magically grow without doing anything. So then we could try to basically copy this down using like a Excel formula, right? I can say, can I just copy this down? If I select that and copy it down, does it do what I think it should? It doesn't, because there's like a 0 there, and it shouldn't be 0. Why? Because that 7%, don't want it moving down. I don't want that moving down. I want that one to stay the same. Everything else should change. So I'm going to delete this. And I'm going to use my absolute references. I'm going to double click here and I'm going to say that one right there, B4, absolute reference is needed. So I'm going to go over here and push F4. Actually, only a mixed reference is needed, but I use an absolute one just because why not? So $ before the B, $ before the 4. We'll make it absolute. That tells Excel not that it's a dollar amount, but don't move it down. Don't do anything funny to that one. Keep it where it's at, Excel. And then we're going to do that thing again. And then if I select them, does it do what we expect? That one looks good. That one looks good. That one looks good. So we can then autofill it all the way down now. All the way down. Autofill. And then the bottom line number still comes out to what we have here, but we have now a little bit more detail about it, which is nice. Let's go ahead and put some decimals over here. Home tab, number, and add some decimals to it. So there we have it. Now let's do it with an Excel formula. This is the magical way that most people just do it, and they can't tell you anything about like what happened. It's just that's the formula you put in, the magic number comes out, which is neat. So we're going to say this is going to be the future value brackets. We're going to use our little thing down below, dialog box, I think they call it. Picking up the rate. This is going to be the rate for the periods, which in this case is in years. If it were in months, be careful. Make sure you're picking up the proper rate for the proper period. The number of periods, we're saying, I believe, let's just pick up the 9 over here. Let's pick up the 9 there. And now, because it is an annuity, we're going to use the payment item, whereas if it were not an annuity, we'd make this 0 or simply have a comma and then put in the present value. But this is an annuity, so we're going to be picking up the 12,000 amount and then enter. So there we have it again, magic. Double clicking on it, I'm going to put a negative before the F to flip the sign, so it's a positive number there. Let's do it with the tables this time. Let's do it with the tables. We're going to say this is going to be the 12,000 times something, and we'll pick that something up from the tables. Just make sure you're picking up the proper future value tables here. So this isn't the value of 1, this is an annuity table, and then we'll say the rate. Make sure you're picking up the proper rate for the time periods covered. This is a yearly rate, so 9 years, 7%. What we want, 7%. 9 periods happen to be in years. That's going to be the 11.978. 11.978, 11.978, 11.978, 11.978. Then I'm going to add some decimals to that one. Decimals here. So there we got it. And let's underline it. And then let's multiply it. This is going to be equal to the 12,000 times that 11.978. Let's add some decimals to it. Home tab, numbers, decimals. It's a slightly different than this number, but pretty close. Why is it different? Because of rounding. What did we expect it to be? If we didn't go 4 digits, it would be more like 11.9779887 instead of the 4 digits out, 11.978. So what do we have once again? 11.977987. 11.978. 11.978. A little bit unusual rounding scenario there, but that's what it is. So let's do it again. Let's do it again. Another scenario. Let's go on to practice problem 2 and do this whole thing like another time. So now we've got the investment period of, the investment per period is going to be 11,000. What if we put 11,000 in for 35 years with a 9% rate? Then how much would we have at the end? What would the future value be at the end of that time frame? So we're going to say, let's do it with a formula again. I'm going to take the outer column being the P times this, and then the inner column, like in here, I want the numerator divided by the denominator, and in the added detail, I'll put it in this side to get this numerator, which has a lot of detail. So I'm going to say, all right, the outer column is going to be the present, the payments, and then inside, I want this 1 plus r to the n minus 1. This whole numerator, that whole numerator business is going to be 1, and then the rate is going to be the 9%. Let's percentify it. Home tab, numbers, percentify it, underline it, home tab font, underline it, add it up using the trusty sum function equals the sum of those two items. Let's percentify that. Home tab, number, percentify, 109% to the power of the number of periods, which in this case is in years, 35 years. Underline that. Home tab, font group, underline, and then we're going to take that to the power of, so this is going to be the 109 shift 6 caret power of 35 years. Let's add some decimals, home tab numbers, just in case we need some decimals there, which we do to make it like more exact. And then we're going to subtract out 1, because that's what the numerator, we're still working on the numerator here. And now we finally did the whole numerator. I'm going to bring that out to the outside now. I'm going to bring it out here, because now we got the numerator, and I'm going to divide that by the denominator in column F. So so this minus the 1, adding some decimals, home tab, numbers, decimals being added, and then underline under this 1 possibly, home tab, font, underline. So there we have that. There's the numerator. Then we have the denominator. So that's R, just R. So we're going to say R is the denominator. Let's percentify it. Home tab, numbers, percentify, underline, home tab, font, underline. Now we've got the numerator and the denominator. Let's take the numerator and divide it by the denominator, because that's what we do with that when we have that. So we're going to take the numerator divided by the denominator, add some decimals, home tab, number group, decimals being added, underlining it to, home tab, font, underline, and we're finally going to get to the future value. Future value. Finally at the future. The future's here. We're back to the future. And this is going to be equal to the 11,000 times that thing we just calculated. And there we have it. Let's add some decimals. Let's go to the home tab, numbers, add a couple decimals. So there we have that. So, 2,372,818.30. That's what we'll have after 35 years of putting in that 11,000. Hopefully that we can live on that, but inflation these days is a little scary. I don't even know. I don't even know anymore. I don't know anything anymore. But we're going to say now let's do this in terms of periods, calculating this out per period. So let's say we've got period 1, 2, and then I'm going to auto-fill down the periods. We got 35 periods, so this is going to be a long kind of thing here. I'm going to bring this all the way down to 35 periods. And because we have Excel, though, it's no problem. No problem at all. I'm going to center these, home tab, alignment, and center them. And then the first value we're going to start off is at 11,000. And then we'll just calculate a couple of them and then use Excel to do the auto-fill down. Really useful to be able to do this type of calculation. And it's easy with Excel because you got autofill. So this is going to be equal to the 11,000 times the percent, which is 9% per period, in this case years. That's going to be the 990. So if we take then the 990 plus the payment that we're going to make is going to be 11,000. We make the 11,000 payment each time because it's an annuity. That means that last time we had 11,000 plus the sum of the interest and the payment we're going to put in this time. Closing that up, there we have it. Then we're going to take that new amount, the 22,990, times the rate, once again 9% per year because we're doing it on a yearly basis. The payment we're going to put in, again, 11,000 because like it's an annuity. And this is going to be equal to the 22,990 plus the sum of the interest and the payment, closing it up. There we have it again. Let's do it again one more time. We're going to take the value times the rate, which is going to be 9%, and then we're going to say we're going to put another 11,000 in this period. Last time we had 36,059 about because it's rounded, plus the sum of the interest that we got plus the payment of 11,000. That brings us up to the 50,304. Now, if we were to use autofill to copy it down, let's just do it one cell down and see if it does what we want, which it won't. It'll get messed up, but we can then we can figure out why and fix it. So I'm just going to take it down one time, autofill. And that 0 doesn't look right. Why? Because that interest rate moved down. That one I don't want it to move down. All the other ones I do want it to move down, but not that one. So I need an absolute reference. So I'm going to delete these and then double click on this one. And that one, which happens to be in cell B4, we need to make it an absolute reference. I'm going to do that by putting my cursor in B4 and selecting F4, putting a $sign before the B and 4, or you can simply put a $sign before the B and 4, or you could use a mixed reference, but it's easy. Then you got to figure out like which mixed way you want to go. So I just do an absolute reference and that should work. So then enter, and then I'm going to select these and just take it down one time just to test it and say, did that do what I wanted to do? It did. Did that do what it did? Did that do what I wanted? It did. Now we can take our autofill on these 3 cells, fill handle, and take it all the way down 35D. It doesn't even matter how long it is because we have Excel. We have the power of Excel. So that's going to be the 237,218. I think that's the same as what we got before. Let's add some decimals here. Home tab, number, we'll add a couple decimals. So there we have it. I think that came out to be the same thing, right? All right. So now let's do it with Excel, the magic way. This is how you do it if you're like a magician. This is going to be equal to the future value, brackets, the rate, And remember, pick up the rate that's applicable to what you're dealing with. We're doing years, so we don't have to do anything funny like dividing by 12 or anything like that. And then comma, we're going to say the next thing according to this dialog box is the number of periods, which I'll pick up down here this time. There's 35 periods, comma. And then because this is an annuity, we pick up the payments. If it were not an annuity, I'd hit 0 or comma and then the present value. But payment 11, enter. There we have it. Gonna double click on it again, put a negative before the F to flip the sign so it's a positive number. Once again, we came out to the same amount again, but in a different way. This time, the magic way. Now let's do it with the annuity tables. 11,000 table amount. We have 35 years at 9%. So remember, you got to make sure you got the right periods and percents lined up, whatever they are. If they're monthly, you got to make sure you're using the right pair there. So we're in years and percents. And now I forgot because I was 39 and 35. 9% and 35, which is way down here. And that's going to be, I think this is it. This is going to be the 215711. That's going to stress in my memory right there. 215.711. 215.711. 215.711. 215.711. Adding some decimals, home tab, numbers, decimals. And then let's add an underline. See if I remembered correctly this time. That's like 7 digits. That's like the maximum that your memory does, isn't it? That's like as far as normal memories go, I think. Home tab, numbers, adding some decimals. So we're at the that's pretty close. It's different because of rounding. Notice that 215.711. What would we think it should be if I was to calculate the table out more than 3 or 4 digits? It would be this number divided by that number, which would be 215.71075. 215.7110. So it's rounded. I believe it's correct. Let's just subtract these out. Because this is a large number, the rounding could be a little bit more, it's not bad, a little bit more significant than normal, but obviously not something that would affect it decision-making purposes. But note that it is something that the test questions can force you to choose one answer or another based on multiple choice answers to try to get you to use either the tables or the formulas.